Hello. Welcome back. Happy Saturday. So I just got back from a friend's place, from Sudi's place. It's very nice. Just got to catch up, talk a lot about things. Always a good time. And I guess it's a little bit late, but I was thinking maybe I'll spend a little bit of time just checking out Hugging Face, which I just learned about a little bit earlier today. Wanted to play around with that, but before that I wanted to finish my dailies and kind of test out this setup right now where basically you can see what's on my phone. And I'm just gonna do my regular Duolingo because I got to do that before midnight, and then maybe play around with Hugging Face for a bit. There's a lot of stuff I want to do, not enough time, so let's get right into it. Hope you're doing well. Man, I really want to finish this tree because I think I got. It's kind of weird because it's like I think I got everything else done. I almost finished it, and then they added more stuff. Not happy about that, but it's whatever. I think I finished it once, and then they added more stuff before, so it doesn't really matter. I don't remember. Don't even remember where I was. Was it this one? Okay, let's just do this. Man, I had to do that 5 times.你是要 medicine, well, 你吃药吗? Why is this a weak word? I know this word already. Well, this is interesting because I can't hear. Alright, gonna have to fix that setup. Let me see if I can fix something here. Cool, okay. I think that helps. Geography is difficult. There are a lot of things I don't understand. There are a lot of things that I don't understand. And I'm not going to say really. Well, first of all, because they don't have it there. And second of all, usually they leave 4 words at the end. I want to cancel my room booking. 我要取消is cancel. I just look at the kanji and that's like erase. And then 订房 fang is room, ding is, I was thinking da, but ding, order room or something like that. Reserve. That one. 废票机票如果颜色地理冷 I really like that purple dress. 我很喜欢我真喜欢那条紫色的裙子
这条裙子有点短。
药 Okay, maybe I should just go through this pretty fast.
瓶子、刀、
筷子分钟 My older brother likes purple the most. 我
哥哥
最喜欢紫色的 Wait.
过去3个月我在德国工作。
过去3个月我在德国 For the past 3 months, I was in Germany working. 3 months, I was in Germany working. I don't even know. I keep on hitting it too fast. I don't know what it corrected me. I bumped into my good friend in the park.
在公园，我遇到
了我
的好朋友。
Grammar
句子、
语法 cancel 取消
导游、句子、同事。
I'm not actually remembering any of this. I bumped into my teacher at the airport.
我
在
机场
我遇到了我的老师
我要取消订房。
I want to cancel my booking. I want to cancel my room booking. 这条
裙子有点短
有点短 For the past 去过3个月我在德国工作。我的哥哥最喜欢
紫色。
过去3个月我在德国工作。
3 months I was in Germany working. Oh, that's what it was saying. That's the same thing.
过去3个月我在德国工作。
For the past 3 months, I was working in Germany. Fine. And usually when that happens, I feel like it's telling me I don't know English. It's not that I don't know the Chinese part, I don't know the English part. That's how I would say it. For the past 3 months, I was working in Germany. For the past 3 months, I was in Germany working. Same thing in my mind. It's probably some slight differences. Yay. Okay. Well, that was pretty quick. Relatively quick. It's gonna be a long way before I get back to the end there. Duolingo is fun. It would be fun working on this app. Wonder if they have any new languages. Doesn't really look like it. Ooh. Nope. Oh well. Okay, let's go to Hugging Face. So earlier today I just learned about Hugging Face. What is Hugging Face? I keep on saying that. So if you know GitHub, then Hugging Face is pretty much GitHub for machine learning. Oh, I just realized I need to make this a lot smaller. Okay, this is gonna be awkward. Let's see how this works out. Okay, now you can actually see. Okay, so this is basically From my understanding, I only started learning about it today. I heard about Hugging Face a lot, but only today I made an account and actually bought the Pro because I want to get good at it, because I want to get into ML stuff. And from my understanding, this is just like GitHub. So, you have your own profiles and you have repos. And there's at least two different kind of repos that seems important. Your models and your data sets. So in machine learning, in AI and machine learning, basically the whole goal of machine learning is to create a model. Now what a model is, wow, I don't even know how to explain it. Maybe ChatGPT can help me. In a sentence, what is a model? A model is a computational framework or algorithm trained on data to make predictions, classifications, or decisions based on new input data. Okay, so so in machine learning, yeah, the whole point of training a machine learning model is to get a model, and that model is basically, yeah, it's an algorithm. It's a trained algorithm. It's an algorithm that's created not explicitly by human code, but through mathematics and data. So to train the model, you need a bunch of data. Yeah, let's just say that you need a bunch of data, and through another piece of code, through another piece of algorithm, it takes the data and it starts to construct the model. And if only I had like a way to draw this out or something. I have an image in my mind, and it's probably a lot easier to explain it when you have some visuals. But basically, you take the data, you run it through a training algorithm, and it spits out a model. So Hugging Face is a place where you can collaborate on machine learning, and it gives you a place where you can host, you can keep your model code and your actual model itself and the data sets used to train that model, and allows you to collaborate with a lot of other people. So I can see a lot of other people. I can see a bunch of models and data sets from other people. Like right here is all the different models that are available to me, and different kinds of models too. It's like multimodal, which is like multiple types of inputs and outputs or outputs, computer vision stuff. So usually it's the input of an image or an output of an image, I suppose. I'm not really sure what the zero shot is. So I'm just going to be trying to learn stuff as I continue. So if I say something and it doesn't make sense, that's probably because I don't understand it either. But anyways, computer vision stuff, NLP stuff. So I guess that's understanding English words. That's the point of some of these, like summarization, audio stuff. So audio output, audio inputs, tabular. I'm not too familiar with this. Time series. That's usually with like logs and such. And I guess predicting behavior, maybe like stocks or I'm not sure. Reinforcement learning. That one's kind of interesting. Graph machine learning. Whoa. Okay, so reinforcement learning I'm interested in from like video games and I guess maybe cars. That's basically where it learns by doing something and it's given a reward function. So I guess there's different types of reinforcement learning algorithms, including genetic, or is it called generational? Something along the lines of like Darwinism, where it spins off a lot of agents. Wait, is that the same one? Yeah. It spins off lots of agents to try out an environment. They have terms for it. Agents, environments. They put the agents through the environment and are given a reward function. And there's some randomized values in there, weights and biases and And let's say you have 10 different agents that runs through the environment doing random stuff essentially. Some of them will have higher reward values, some of them will have lower. The ones with the highest reward values moves on to the next generation and have offspring. And their offsprings will have some variations to them. And some of them will have like random mutations. So then those will run through the environment and try again. Hopefully they'll have higher reward functions, and that repeats on until however long you want, I think. That one's pretty interesting. I want to play around with that sometimes. I'm not sure what this is. So I wonder if I just click on one of it. That does not tell me much. Okay, and so besides models, we have data sets. So it should contain a lot of data. And I guess, whoa, that's terabytes. Holy. Hugging Face staff. And this seems like an official thing. I wonder. These are gigabytes. What is this? Hugging Face FW. So this looks like a tabular data. FineWeb. The finest collections of data the web has to offer. FineWeb consists of more than 15 trillion tokens of clean and deeply duplicated English web data from Common Crawl. Oh my god, there's so many things I don't know about here. Fully open replication of refined web with the release of the full dataset under ODC by 1 license. Open domain common creative. We managed to push the performance of FineWeb well above that of the original, and models trained outperform models trained on other commonly used high quality datasets. So what's refined web? What's Falcon LLM? Falcon LLM is a type of LLM. Here's some Falcon ones. I think I need a goal for tonight. Besides just like randomly going through this and trying to understand what's data trove. Hugging Face. It's a library to process, filter, and deduplicate text data at a large scale. Okay, I think I'm going to close some of these tabs, but here I was kind of researching a couple of interesting things. Let me see if I can recreate my thought process from earlier today. Where did I start? I was doing some research. So my friend Naveed, basically the problem I was trying to solve was understanding receipts. That's kind of a hard problem. My original thought was like, well, maybe we can use OCR on the receipts, right? I think there was like a framework, JavaScript OCR. Yeah, tesseract.js. So this seems to be a way to do it on using JavaScript, either on the server side or the client side. So if, let's say we can do it on the client side, just run a website, you upload a photo or take a photo and it scans the receipt. And actually, I think I got it from ChatGPT. First, I was like, I want to have an API, upload a receipt and return data about the receipt, stuff like total cost, numbers, item purchases, what the items were, tip. And it gave me a couple of interesting ideas, setting a backend. Oh, right. The first idea it gave me was OCR, optical character recognition. And it gave it to me in Swift. It knew that I was a Swift developer. And I don't know. I'm playing around with Swift now, but I think doing a backend, Swift's not really ready for that at all. I guess it could be. There's a lot of things I think that could be better. So I just asked it, hey, wait, actually I think later on I asked it to do it in JavaScript or TypeScript. I think I just continued by saying TypeScript. Oh yeah, maybe I did say that. TypeScript would be a better option as it's more mature. Also thinking of using AWS because yeah, I'm more interested. I was thinking about using AWS to like put in Lambda and stuff like that. It gave me more generic stuff, and also CloudFormation. I mean, nothing's wrong with it. I just haven't played around with it, not too familiar with it. It's kind of annoying whenever it does this and spits out code that I don't need. So I was like, can I just see the Terraform? And it gave me generic stuff: S3 bucket, DynamoDB table, IAM roles, generic stuff, variables, and outputs. I was like, that's fine and all. But then I was like, how do we process the receipt? So like the actual logic. And it went back to the OCR logic. And it recommended Tesseract for OCR. So then when I took a look, wow, I guess it did spit out this stuff. I didn't even look at this yet. Let's ignore this for now because it's not too relevant. Just looking into that, I'm wondering we could do this without a server. So like I said, just on the client side, read the receipt, parse out the items. So then we don't need a server to, the OCR, I don't think it takes that much. It seems pretty standard, especially with JavaScript. But maybe we can do it all client side. I don't know. It's just a thought. If we can avoid a server, that would be ideal because when you're at restaurants, you don't have internet sometimes. And so it says, certainly you can do it directly on the device. Eliminates the need for a server, more responsive user experience. Yep, pretty standard. For web applications, Tesseract directly in the browser, mobile. Then it gave me Vision Kit for OCR, and then Android uses Google ML Kit. Interesting. Kotlin example. Okay, which is cool. Oh. Okay, so then basically it's a regex. Just reading the jobs, the Android stuff for now. Let's focus on the iOS object because I'm doing iOS in the daytime. Show me that using SwiftUI. So it spit out the SwiftUI, and this one's pretty straightforward, I think. You can ignore this part. This part's generically pulling the text from an image scan, camera scan. Yeah, we don't, you can just ignore this. It's literally just pulling the text from the image. And then here's the UI for it, where there's a button to scan the receipt, and then it shows you what the OCR is, I think. And then there's the receipt scanner view, presented in a sheet. So that's just generically the UI. It hasn't even touched the logic yet here. Then I'm like, all right, so after scanning and getting text, what does the logic look like to get back the info? Ignoring that. Here's the most interesting part, I think. I'm just going to jump to the meat of this all, where basically we're trying to pull this receipt data here, where you get the total cost items, if there's a tip on it, an item count, which, that's just the items.count. But to get all of this data, all it's doing is after pulling the string, it's just doing regex. Regex to get the total, to get the tip, to get items. And this says example. So I don't think that was too good because it's not always going to say total. It's not always going to say tip, right? Different receipts, there's like so many different receipts. And what if the OCR is bad and it doesn't read it properly? Well, it's going to completely miss it. So the accuracy is just going to be really bad. And maybe it's okay for the first time. Like maybe we might have to have a UI to fix it after scanning. But we could do better. We could do better. So I said, it looks good. Let's focus on parse receipt. Could this be more flexible? Like sometimes total might say balance or some other text. And I get that because I have a receipt here that says balance. So I was like, yeah, it's not going to work for my receipt even. So the next one it spit out is a little bit more flexible. It adds a couple of more patterns: total, balance, amount, tip, gratuity, Item descriptions. I don't even think it'll work for this receipt. Like, not too happy with this. Just regex isn't the best. It could say a lot of other things. It might not even say anything at all. Could have a high failure rate. I don't know. I haven't tried it yet. Same receipt data. Oh, okay. Well, I guess that's the end of that. So then the idea became, all right, low error rate, not great. What's the what can we do better? Well, probably with ML stuff. And I think I just what did I do? I said, in theory, training your own model probably isn't that difficult. You just need a bunch of receipts. Someone needs to say what the correct answer is for those receipts. Maybe ask ChatGPT to spit out like a neural network to help training. Put that into like TensorFlow or SageMaker. And just like, maybe we can start with the regex, but then later on replace that algorithm with that function with the algorithm, with the machine learning model. And I think it should work. And I don't think it's that difficult. There was a question on how long that would take. I was only thinking of like a smaller data set. Maybe there'll still be inaccuracies with a small amount of data. And then at some point, I think I remembered Hugging Face had like a lot of data. So I said, what if there's receipt data on here? So I said, receipt. Oh yeah, then I saw a couple. So that kind of piqued my interest. I was like, all right, here's a data set for invoice receipts. I was like, oh, what's this? So it's funny how, because I understand this a little bit more. Whoa. So use only LLM model to convert an invoice or receipt JSON object could reduce the conversion step, reduce resource utilization and deployment dependencies, result better performance. So the output, this one's for invoices. So you get a number, a date, seller, client, and I think like this could potentially work. I think it spits out XML before it spits out JSON. But anyways, here's the files. And sorry, I think I'm in a model. Where's the data? Well, did I even see the data? Receipt. How did I do this? Here's the data set. Invoices and receipts. This one. I don't remember. Either way, I found another really interesting one. Because invoices wasn't what I was looking for. It was more for receipts. Which one did I see? Was this one? No, it was a Chad. I think it starts with a C, the user at least. Let's try it again. Receipt. Did I search for restaurant? Donut. Is this one? Adam Cod, that's the one. Donut receipts. Okay. I don't know. The search showed me different results earlier, or I typed in something different. Anyways, I think I found this data set first. Or I might have found the model first. Anyways, so this has if you check it out, it's receipts. Which is like, great. This was exactly what I was looking for. So like there's here, so this is the data set. You have your image, and I guess they have a ground truth, which is a dictionary. And this is like the data that's inside the receipt. So the truth is, this is like the store name is Chuan Korean restaurant. Store address is that. I feel like this data set has a lot of inaccuracies too, because if you look at the store address, it's like there's no spaces. They probably put it through some OCR and then didn't clean the data. And I think they said that as well. It's made from a subset of this and formatted for donut model. There are numerous errors in the data set. Privately enhance it, and then like we can contact them for further details. I think you can, oh yeah, you can buy the upgraded data set for sale. But this was a decent starting point, I thought. Oh, this is interesting. This is not even in US. This is European. That's pretty cool. But there's I guess here's the ground truth. Anyways, here's the data. And there's a lot of data. So like originally I was wondering, can I see some receipts so I can try out to build out the data set? But this already does it for us. So immediately I'm like, wow, that saves a lot of time. Assuming that the data set is correct, which like they said, there's a lot of errors. I'm okay with that. At least we have images of some receipts. I don't have to like take time to why does it say tags croissant? Take time to get the data. The data's already there. And that's what I'm realizing, the value of Hugging Faces. You get the data because other people are making it for you. Well, not really for you, but they're sharing it using some sort of license. And this one, it's Apache 2.0. So there's conditions to it, but Apache's is generally an open one. I think you can do it for commercial purposes and such. What is this? You can do pull requests and discussions. That's cool. You can also see the files. I guess what does pickle mean? The file. So this is just a Git repo. You have Git attributes, which a lot of it's for Git LFS, which is for large files. This makes sense. Yeah, anything that are large files will go into Git LFS README, which is the dataset card, and then here's the zip file with the actual receipts, and I guess the tables, maybe in pickle format. And this is the one that's in Git LFS. Cancel. So I could just download that if I wanted to. I don't want to yet. Whoa. And I guess I can browse the data set. So this is cool. This is cool. Okay, but anyways, going back. Whoa, not that far back. So this Adam guy, who is this guy? Look, wow, he's actually done a lot. Whoa. This is the model that I was looking at that used that data set. So data set used to train, and that points to it. So you can see what data was used, and you can see the model. And I was thinking maybe we can just use this model, except one problem that I realized a little bit afterwards was that version 2 model. Well, it's not really a problem, but if we wanted to do it commercially, this license for the V2 model is CC by NC. NC meaning non-commercial. So if we wanted to build an application or something from this model, using this model, I don't think we can, not commercially at least. But if we wanted commercial use rights, we can contact this person. But the V1 model is still under MIT, so I think that one allows for commercial. And this was pretty much what I wanted. And I guess this is a pretty cool explanation of kind of what's going on. So with the training, you have your image and your data and prompt. No, this is... I guess there's 2 inputs. So what they're showing here is given a receipt and a prompt. Like the prompt here is a question: what is the price of chocomochi? You can see here visually for yourself. Chocomochi, there's 2, so 28. So in theory, 1 chocomochi should be 14 because it's half of this. Since there's 2, the image goes into the transformer encoder. The prompts goes into the transformer decoder, as well as the output of the transformer encoder. Both goes into the transformer decoder, and then it spits out a sequence. So I'm not too familiar when I'm talking about this. I know, yeah, I'm not too familiar with transformers sequences yet. But it seems to classify it as a receipt. The answer is 14,000. I mean, it's 14. I don't know if that comma is supposed to be a dot or something, or I think Europeans use commas sometimes. And then that's the item, I guess. And then you can also convert it to JSON, I suppose. Anyways, I don't know. I think the model is the donut part. Later, I realized. Sorry, I'm trying to think through my what did I do today? Okay, now I remember. I was thinking, how do we use this? Let's check the files. Like how big is this? Can we put it into the app? And then I just looked and saw the two biggest files. Well, at first I saw there's a dot model. The rest of it's JSON. So I was like, maybe that's just, I think that's just kind of like the model code. I guess it's not really code. We'll take a look at it later. But that's the configurations. And then the two biggest files you can see it's marked with LFS is 1 megabyte and 809 megabytes. I think this is the actual, so, oh yeah, it's a dot model and a dot safe tensors. Oh, cool. So you can see all the tensors here. But my first question was, what files do I use for the model? Is it .bpe or safe tensors? And it's saying that the tokenizer, wait, hold on. So the specific file depends on the type of model. Tokenizer file is the model file. This is a byte pair encoding tokenizer. Not sure what that means. You would use this file for tokenization, which is the process of converting text into tokens that the model can understand. Okay, so this turns text into tokens, and then you have your model weights .safe tensors. This is a newer format for storing model weights safely and efficiently. If you are loading a model, you might encounter this file format. It's used to store the actual parameters of the model. So I have a rough idea of what that is. This is based on neural networks, where the whole process of training deals with nodes in a neural network that has weights and biases, some of them randomly generated, and then as you're training, you go through activation functions, backpropagation to correct for errors. That's using a lot of different things in your algebra, calculus. I think there was something else. But after your training, you have a final set of weights and biases. Does it say this here? Actual parameters. Yeah, model weights. And that's stored here. And ideally, if you train it enough and you can test the model, it should have a relatively high rate of accuracy, or that's what you're aiming for at least. Just off of the weights. That way, anytime in the future when you give it new inputs, it'll give you an output, and hopefully it's accurate. So the model weights would be in .bin, .pt, or .safe tensors. Tokenizers are .json, .text, or .pp, .model. And they tell you how to use it. This is Python code, so you have the auto tokenizer. You put, well, you're importing transformers from that, and then you put in the model into the auto tokenizer. So you get the tokenizer, you load the model, you tell it what model class, and then you load it from a pre-chained. So you have a model and tokenizer. And it doesn't really say too much more. I was like, all right, if I want to put into app, do I need both? And yes, you need both. I think this is the same thing it's saying. So you get the tokenizer, you get the model, you have input text. You put the text in the tokenizer. It returns tensors. And with that, okay, so a it's a tokenized version of this text, and you just run that through the model, and you get your outputs. So in Python, it looks like you can just pip install the transformers and download. Oh, interesting. It comes with the CLI for the transformers. You download your model, load it using Python, and you can also deploy it and run it. And I think this is where Python APIs got popular because of what you can do with machine learning. And I was asking about the transformer and the donut transformer because as I was looking through this, I was trying to figure out what this actually spits out. I guess here's sample code. What it actually spits out is, I still don't really know. I mean, it looks like here it gives you information about it. Like it knows the items and it knows how much it costs. So you have a processor pre-chained from this repo, and then the vision encoder decoder model. That's the same. Model.to device. A device. What is this? Torch. CPU. Okay, so I think we're saying when we run the model, run it on a CUDA, which is I think the GPU, if it's available. If it's not, we'll just run it on the CPU. So this is like configuring it where to run. We're defining two functions, load and preprocess image, generate text from the image. And I think this is like getting the text from the receipt, maybe. The prompt is a receipt. You get the input IDs. Why is it doing it twice? I guess we get the tokens of the input IDs and run it through the device. Okay, and then the generate outputs is you call the model and you call generate on it. Pass in the pixel values from the image. Okay, I don't think I read through the code too much, so I don't really know what token JSON. And then eventually the output, you do something, remove the task start token, you remove the start token, you change the token into JSON, and then you return that. Okay, well, I guess that's how you run it. I don't really get it, but okay. Here's an evaluation of it, where the accuracy is like 89.5%. So it seems mostly accurate. There's going to be some inaccuracies depending on how accurate you want this to be. I don't know what the rest of this is. What is this? Okay, so you can put this in the metadata so everyone else can see more data about this model. So it looks like the model size is 202 million parameters, and the tensor type is int 64 float 32, I think. There's no serverless inference API that we can use right now. been turned off. It's fine-tuned from this model. There's a base model. So whenever you build a new model, sometimes you specify a base to fine-tune it from. So I guess like you have a model and then you can continue fine-tuning it, adjusting the weights even more, training it a little bit more off of this data set. Right, so you have the, and it's over, it's like almost 1 terabyte, which I think is pretty big. I mean, I think if you download an app, it kind of alerts you after 400 or 200 megabytes if you're on data. I'm not sure how big apps are getting nowadays. And then I guess you can add other tokens and stuff and configurations. I wonder if there's like an initial weights. I'm not familiar with any of these right now. Nope. Not familiar. But it looks like they were still committing even 2 weeks ago. Oh. Sample with parsing issue. Membership number. So yeah, it's inaccurate. For now, there's not much to do except for hiding the problematic items on your receipt so they won't be picked up by the model. Thanks, appreciate their quick response. Yeah, so there's issues, not ideal, but again, it's a place to start. Maybe we can fine tune it some more. Let's see, V1 model remains available under the MIT license under the V1 branch. So you can clone it. I don't know how you can switch branches with this. Oh, you can edit it. And it looks like you can train it, deploy it, and use model. So when you train it, you can say optimize training with SageMaker, deploy it with SageMaker, use the model. This looks like VS Code. What happens if I click on that? Oh, okay. So it gives you code on how to use it. So you just import it from pipeline, pipeline, imaged text, because that's what we want. And then we specify this model. You can load the model directly. You get the auto tokenizer and the auto model. That's interesting. Maybe we should try that out. And it's almost midnight, so I think I'll go about 30 minutes more. But yeah, so that's this repo. The only other thing about this that I found interesting was it kept on talking about this donut based model and like how it was introduced in this paper, OCR free document understanding transformer. So I'm like, cool. It's I guess it's based on this model. I don't know if I can read this paper somehow, or here's a PDF. Oh, okay, I can read it. Maybe I should read this, or tell ChatGPT to summarize it for me. But apparently, yeah, there's that, and then first release in this repository. So then I found this repository. I found 2 repositories. One was that one, and one was fine-tuned from this base one. So if you look at the base model one, it says donut base size model pre-trained only, introduced in the same paper, and first release in this same repository, and it has the same image. So that's at some point I started to realize this one is more about the whole image processing donut thing, which again I didn't really completely understand. Which is when I think that's when I went back to ChatGPT and then say, give me a short summary about Hugging Faces transformer and the donut transformer. Oh, right, because there's something else interesting. Looks like I could do it. Here, I can actually like drag and drop a receipt and try it out. So that would be interesting to do. Okay, so here's the interesting part. When I clicked on documentation, I was brought to this page, like model doc donut. Like, it seems to be on a listed under transformers. So I got really confused because I'm like, this looks like part of the official Hugging Face library or something. Like, there's a lot of other random ones, but it's not all random ones. So donut must be an important one. Right? And they have like a donut processor class. So this must be important. Like a high level concept. So that's when I think I went back and was like, all right, here's a short summary. I guess you can have the transformer library, like you use their transformer library, which is a powerful open source library for NLP, provides pre-trained models, including BERT, GPT, T5, making it easy to integrate state-of-the-art models into applications. And then the donut transformer is a specific model designed by Hugging Face. So yeah, like I said, it seems to be official, focusing on understanding and generating structured data from unstructured documents such as PDFs and images containing text. It combines the capabilities of vision and language transforms to interpret and generate content from complex document layouts efficiently. Can I use it in an app, and how big is it? You can use it in an app. It's designed to handle structured data from making it suitable for applications that needs to process and understand the document. So I think it is useful for receipts. We install transformers, import donut processor and vision encoder decoder model, load them, path to your image, get the pixel values, pass it into the model to generate the outputs, decode the outputs, and here you have your data. I don't know what that is, but size of it, it's around, well, this says it's around 500. Going back to the donut repo, and if you look at files and versions, it's actually 800, so maybe it went up. This is in the .bin format as well. They also have the 1.3 .bp models. So it's still roughly a terabyte. It's not that great. So you can either pre-download the model and tokenize to avoid runtime delays, or you can package them with the app, load them using local paths, smoother user experience, reduces reliance on internet connectivity, which is pretty nice. That's kind of what I want. And then here's the real question that I wanted to get to. Can we get a JSON of the total tip and items from a receipt? Yes, you can. It's designed specifically to handle tasks such as interpreting and generating structured data from unstructured document images. Now it's like giving me a little bit more stuff. Load the document. This is like the same. That's like this. Okay, what? This is like the same thing. Pillow. I don't think it's using pillow at all. At least I don't see anything. And then here's, you can convert it to JSON using JSON.loads. So whatever this thing is. Decode the output to JSON. I don't think ChatGPT is right on that. Like these two are completely different or whatever. And here's the example output. You get totals, tips, and different items. Burgers is that much, fries is that much. And then I think I went on a tangent on like, so that made me understand more about Hugging Face. And I think I started to go on a tangent about ML itself and training because, as I was reading more about this repo, right? So they had this repository in GitHub, and that's the official implementation. So like, this is probably the default one here. Donut stands for Document Understanding Transformer. It does not require OCR, and it shows performances on tasks like information extraction, aka document parsing, and that's like the main thing that we wanted. They also have the synth dog thing, but that's fine. Oh, okay. Here's a demo. They're actually putting in a receipt, and then here's, what is this? A receipt? Yeah. So here it has 3 items: the prices and the count. It gives you the subtotal and total. What is this? Oh. Okay, so it looks like, sorry, I'm learning about it right now as I look through this, but it looks like there's different tasks you can ask it to do. I don't know what chord v2 is, but you can also say doc vqa. I guess that's document visual question answer. So it looks like the output is question, what's the title? Oh yeah, question, what's the title? So here's the question. And here, OCR free donut, which that's the title. So that's pretty cool. It's not just for receipts, it's also for that, but I guess somehow we should be able to say only do it for receipts, because that's the main one we care about. Oh, here. Okay, so they talk about it here. So you have document parsing, okay, all of these are document parsings. And you have different trained models and demos. So what's chord? A consolidated receipt data set for post OCR parsing. We introduced an chord, which stands for consolidated receipt data set for post OCR parsing. Oh. Chord v2 data has been uploaded to the Hugging Faces dataset. We investigated and aligned. Okay. I am entertained. Now my question is, if they've uploaded to Hugging Face, you are free to share, adapt, attribute. So you must give proper credit and no additional restrictions. Can we do this? It looks like we can, for any purpose, even commercially. Yeah, cool. This looks like a good data set. Okay, so where is it? There should be a Hugging Face somewhere, right? Is it this one? Is it this one? This Navier person, I think it's the official one. So here's all the receipts. And they like kind of crossed out everything else. It's gonna be interesting because they don't seem to be from the US. There's like commas everywhere. So the size is 2 gigs for this data set. And this, oh, we can try it out. Okay, so all the receipts are in this one. Indonesian. This is gonna be funny. We need American ones. Indonesian. That's fascinating. The other thing that I wanted to see is, okay, here's the models that are trained or fine-tuned on it. Spaces. Use in datasets library. Edit dataset card. Okay, sorry. What is croissant? Standard format for dataset. Okay, cool. Learning as I go. What was my question? Right. Okay, so what I wanted to get to was I read this section here. the links to the pre-trained backbones. Donut Base and Donut Proto, which is the preliminary model, trained with 64 A100 GPUs for about 2.5 days. And it gives more information about the training done. Proto Donut trained with only 8 V100s, and that took about 5 days. So then 64 A100 GPUs. That's a lot of GPUs. So I was like, okay, this, like, how much can this cost? That's probably like what, an RTX 4090, right? Like, because I'm familiar with gaming and content creation. That's the consumer model one that I'm familiar with. So that one cost about what, 1,600, I think. Well, first of all, here's the 4090, 1,600 sold out. Oh, I kind of want to get one, but okay. So yeah, that's sold out. That'll be great for playing games and stuff. That's what I'm more familiar with. I have a 3090. 4090s sounds a lot better. $8,000 for NVIDIA Tesla A100. 8,000. And you need 64 of them for 2.5 days. It takes a long time to train this data set, it seems. And I was like, 5 days with V100s. I don't even know. How much does this cost? Can you even buy it? Oh, that's a lot cheaper. Look, you can save $300 by buying used. $200. Okay, well, anyways, and you only need 8 of those for 5 days, so that seems a little bit better. So my question to Hugging Face was, on 8. Oh, right. So I was considering. Oh, right. One more thing about this. So $8,000, right? Times 64 of it. That's $512,000. That's $500,000 of just GPUs. That's insane. $500,000. That's if you want to own them, like have a GPU farm. Yeah, I don't have that kind of money. Sorry, just not in the cards. However, you can borrow cloud computing, right? That's a common thing to do. So how much does it cost for cloud computing? So I had to do a little bit of research on Amazon, and I think, right, reading this, they have a EC2 instances for high performance ML training and HPC high performance computing applications, and these ones provide, where does it say here? NVIDIA A100 Tensor Core GPUs. So this is the one that provides it. It's their P4D instances. And if you look here, well, I guess you can see the infrastructure, how they make it so it talks to each other quickly and how it can work together a lot. The instances work together. It provides 8 NVIDIA GPUs. One instance provides 8 GPUs. And here's another view of that. GPU A100s, 8 of them. There's 2 different ones. I think this one's preview because this one's P4DE, which the difference is there's more GPU memory. It's a little bit more expensive. But for the regular one here, it's $32 on demand. The reserved 1 year reserve. Well, I guess if you're doing a lot of training, you can reserve it, which is a lot cheaper. But $32 for, right? So that's when I started asking. If I wanted to train a model using I said A100 GPUs, I think I can use these instances. How much would that cost? And I think it looked it up and it said to use 64 GPUs equivalent to 8 instances for 2.5 days, it would cost approximately $15,000. That's a lot more reasonable than $500,000. I can afford this. I can't afford too many of them, but You know, but I could probably do that once. I don't think I can do it twice. I mean, not like that would hurt me if I did it twice. That would hurt me if I did it once. But it's doable. I can't do $500,000. That's a house. Still got to pay out my house. I need to do that first before I decide to train a donut model. But I can train a donut model for this price. This is relatively affordable. And it looked up through the internet. Oh, so here's some of the analysis. APUs per instance. That's where I learned that one model has 8 GPUs. You need 64 total. So instances needed is 8 at the cost of 32.77. That's the same price we saw over there. Yeah, that's how it calculated. $15,000. And then I was like, can we make that cheaper? And it had some ideas: spot instances, saving plans, reserved instances, optimize the training using smaller instances. Might be more cost effective. These are interesting suggestions. Spot instances. Oh, and then it gave me a calculation. So it seems like spot instances gives you a 70 or more % discount of the on-demand price. So then it drops the price down to $5,000. That's a lot more affordable. I can do that up. I can do that. And be relatively okay. Like that's not cheap, but like it's doable. I could buy a car for that price, but $5,000. Think of it this way: 5,000 versus $500,000. We can train a donut model for $5,000. Not bad. That's where I started to learn about spot pricing. I'm like, what is spot pricing? And it looks like it gives you like 90% cheap, up to 90% cheaper, depending on stuff. It's scalable, but you have to be careful because it can like get interrupted by AWS. So it's great for like when you just need computing power, and you can do like batches, and it can be interrupted. It just takes some time. If you do it in a way where it can be interrupted, you can save a lot of money. So you can request spot instances. Is that the best way to train ML models? And it's an excellent way to reduce costs. So cost savings, it's scalable. Interruption, it can be interrupted, which can be problematic for your training job if it can't tolerate it. So you need to make sure like it checkpoints it, regularly save model checkpoints, so you can resume training from the last checkpoint. Design it to be elastic and distributed so it can efficiently scale out and handle instance interruptions. Auto-scaling. Use spot fleets or auto-scaling groups. Fall back to on-demand. Configure your spot fleet to fall back to on-demand if spot capacity is not available. I probably don't want to do that if I don't want to spend too much money. Otherwise, you can do on-demand, provide predictable availability. Reserve instances offer savings similar for long-term predictable workloads without the risk of interruptions. So that's pretty cool. SageMaker, it offers managed service training with built-in support for spot instances. SageMaker handles interruptions and resume logic for you, making it easier to use spot instances effectively. So with SageMaker, that sounds really good. SageMaker was built to work with spot instances. This is it seems perfect for ML. The cost-effective way, especially combined with strategies for handle interruptions. However, if your training job cannot tolerate that, you might consider on-demand. Okay, so in my mind, that's the only way you should be doing ML. Making it scalable, making it have checkpoints. Maybe there's some models that requires non-interrupted training. I'm not quite there yet. I don't know what situations those would be. Maybe if it's like online training, or I don't know. But right now, my understanding of it is spot instances. That sounds great. And I was also thinking about, well, what about TensorFlow? Can you run TensorFlow on spot instances? Like, do they support that? And yeah, it looks like they do as well. So with TensorFlows, you need to handle the interruption. So make sure you're checkpointing. And well, it looks like they're using the KRS APIs here. So you can create model checkpoints, save weights only. I mean, I guess that's all you need to put. And distributed training. Use TensorFlow's distributed training capabilities to make your training job more resilient. And also gives the same thing for SageMaker. So, you know, whatever. I think that's when I read up on, let's close some of these. Don't need this. TensorFlow distributed training. So like they have a whole thing here. Look, and they have like a strategy to train in a distributed way. So it's easy to use, good performance, easy switching between strategies. I guess one good thing about this as well is if you ever want to stop it during the middle of training and like adjust it and resume, you could like fix the data, resume and stuff like that. You could do that. So that's an interesting idea. Let's see. So synchronous versus asynchronous. You can do asynchronous, and then you can also train on multiple GPUs or on cloud CPUs. So there's multiple ways you can set up the training. Mirrored strategies. I have no idea what that is. Also, that's where they were saying some stuff like Colab, and I learned that Colab that's Google's I think it's basically Google's SageMaker, where you can train models. It's like a Jupyter notebook that can run on their own cloud instances. And I also talked about one other thing. I mean, they talk about a lot of stuff here. Basically, they talk about TPU strategy. Oh yeah, you can run TensorFlow on tensor processing units. They're Google specialized ASICs. Yeah, they're basically like EC2 instances, but Google's version of it. Okay, so yeah, you can run it on there. So back to ChatGPT, and I was like, would it be cheaper to use Google's cloud TPUs? It can be in a cost-effective way. It's basically the same thing, and it gave a couple of different prices. One of them was with TPU v2 and v3, and I don't know too much about the differences there, but it looks like they also have preemptible TPUs, which is similar to spot instances, but with the possibility of interruptions. So it sounds exactly the same like spot instances. So the pricing, this one's $32 per hour. Spot instances is about $9, assuming 70% discount. On demand requires 8 instances. That's $16,000. We kind of discussed that. It was like around 15 before. I don't know why that's different. Why is it that different? Why is that different actually? Times 64? Oh, times 8. That's 2.5 days, I guess. 32.77 times 8 instances times 64 hours. Well, that seems to be the right price. Anyways, about $16,000. Cloud TPUs, if you use version 3 for comparable performance, it's about $8 per hour. It's cheaper than that, but I guess you need more. The number depends on the models and workload, but assuming 64 TPUs for comparison. So that's 64 TPUs Here you only need about 8. So this is saying like one TPU has basically one A100. So you need a lot more instances. At $8 an hour times 64 hours, that's 32. So that's like double. But you can also use preemptible TPUs. That's what they call their spot instances. It's approximately 50 to 70% discount, assuming 60% discount. There's that. It's still about 13,000. That's still a lot. That's almost the same as the on-demand. So it seems like AWS is a lot cheaper. And I was considering like, well, what's the difference between A100 and RTX 4090? And basically what I got was, and A100 has more memories and more bandwidth. And it's like a little bit less power consumption. So it's more efficient for that kind of stuff. 4090 is actually a little bit more powerful. But it's less memory, less bandwidth. It's more powerful. So like, oh yeah, it takes up more power. So it's 82 teraflops versus 19. So the floating point 32 is a lot better. Floating point 64-bit performance is... This doesn't have 64-bit. Okay, I guess. So it's good for gaming, content creation, and experimentation. So I'm like, I kind of want that. But this one's better for data centers, actual AI, ML training, high performance computing. And then I'm like, why does it take 2.5 days? It talks about like the number of layers, the architecture used, which is the swine transformer, but computationally demanding due to its self-attention mechanism and window-based operations. Input size. The input size, this is images. It's large image size, so I guess that adds complexity. The data set for 11 million documents and another data set with 500,000 documents in 4 languages. So a lot of data, a large model complexity. I guess that just takes a lot. And then I was like, I wanted to compare it, right? Like, how long would that take on one of the A100s or one RTX 4090? And I think what it's basically saying is, there's like a line here somewhere. Oh yeah, it's trying to tell me like, here, benchmark it yourself. And I'm like, let's do this in theory without running code. Like, yes, you can estimate the theoretical. Gather specification. So you need like teraflops, memory bandwidth, and power consumption. Those 3 seemed pretty important. I think there's a few more things. But basically I was like, so 3 important numbers. T-flops, floating point per second, 1,000. I don't forget what that means. This is basically like the speed of it, how much memory bandwidth is available, and power consumption. Teraflops measures the GPU's computational power, indicates the number of floating point operations per second, float per second, terabyte floating operations. Higher means faster. Memory bandwidth, so it's like how fast it can be read from or stored. So that seems to be important. It can handle larger data sets and more models without bottlenecks. Power consumption. It affects the operating costs and thermal management. Less heat, which is important for local and cloud. Other factors includes VRAM, video RAM. I think that's pretty important. So you need enough of that. I think the A100 had a lot more. Sufficient VRAM. Interconnects. I guess that's like the connection of to the computer and other stuff. So the A100 I think has NVLink. The 4090 has PCIe, which is pretty standard on consumer grade motherboards. Allows the GPUs to communicate with each other and the CPU. So I think like the A100 is built to talk to each other a lot better than the 4090. So you can have a better multi-GPU setup. So that's pretty important. The architecture, so Ampere and like, what is it? I think one of it uses Ampere. The other uses Ada Lovelace architecture. I don't actually know what that means, but it offers improved performance and efficiency, I guess. Oh yeah, here it is. A100 is Ampere. 4090 uses Ada Lovelace. Interconnects PCIe 4.0 versus, and like this one's, I think, a lot higher. I don't know what this one is, but this one's 600 gigabits bidirectional. So the interconnects for the A100 seems a lot better, slightly lower power consumption. VRAM is a lot higher, and on the A100 up to 80, let's say 40 even. So it's a lot more than 4090. The memory bandwidth is a lot higher on the A100. The teraflops is a lot higher on the 4090. See, 35 versus 19. So the single GPU, the single card performance is a lot better on the 4090. But yeah, so in general, 4090 is better for like consumer level purposes, video gaming, experimentation with AI, ML. I kind of want a 4090 now, but I guess it's sold out. So if it takes 64 A100s 2.5 days, how long would it take for one? And then it did some calculations. Basically, I think it assumed assuming near perfect scaling. It's not always the case, but just divided by 64. What is it? So it's 64, or is it multiplied? So it takes 60 hours for 64 GPUs. So you multiply I guess you multiply it by 64 times. So like you're doing, one card will be doing the job 64 times longer, assuming perfect scaling, which is that long, or 160 days. That's like what, half a year, 6 months? So if you spend $8,000 in 6 months, you can get a donut model. That's quite a while, quite a long time. What about the same thing with one 4090? I think it's calculating the teraflops. So there's a performance ratio where it's like 1.83 faster. It's about 80% faster, I think, because just purely from the teraflops. So if it takes one A100 that long, then you divide it by 1.83 to get 2,000 hours, which is 87 days or 3 months. So it's cheaper and faster, which is insane. $8,000 will take 6 months. $2,000 will take, it's a little bit less than $2,000. 1,600 would take 3 months. I guess so. A100s are only faster when you have them in scale, because you probably can't scale up 4090s that much. And maybe there's something, I don't think they've really talked about the memory aspect or the bandwidth aspect here yet. Who knows? Maybe that is actually a factor. But right now they're just doing pure teraflops. But how much power would that require? So if you calculated the requirements, like for 50 watts, for all of those hours, 2,000 hours, that's about 944 kilowatts of electrical energy. And the same thing for the A100, it's 1,500. So 900 and 1,500. So this is a lot longer. I guess you're running it for, it's interesting because it's only 400 watts versus 450. But it's running like twice as long. It's 6 months versus 3 months. So yeah, because it ran for 3 months more, it's like it's almost twice as much. Not quite, but almost. And the average kilowatt hour cost is 13. So with the 4090, that would cost about $100 in electricity. For A100, it costs $200 of electricity. So 8,200 versus still under, that's like $1,722 for 3 months. 4090 seems pretty nice. So yeah, that's what I was learning earlier today about the state of machine learning models. And I was hoping to try out a model. Maybe we can do always do something simple. What about spaces? Like, can we try spaces of the week? Let's try some text models. I know what some runtime here. I know what some of these are. Like YOLO, I think is object detection, object categorization. Open ML leaderboard. Open GPT is interesting. Dolly. What is this? Tune Crafter. You can upload an image, prompt, and you get. Here's some examples. Whoa. Oh, oh, this is cool. I just heard about this on YouTube the other day. So this is the one where you provide 2 images, image A, image B, and it generates the interpolation between them. So like the in-between frames, this keyframe 1, keyframe 2, it's 2 images, and this created at a rate of 10 frames per second, just like the older Disney days. Oh my goodness. Is this for real? This doesn't seem that bad. I mean, I think I can see some artifacting and like in the places where it moved, but it's honestly not that. I would watch this. This looks like a legit anime. I think I would watch that. Walking Man. What if we did... So I'm... what if we said 30 frames per second? So I successfully... I hope this doesn't cost... I guess I'll find out. But I'm creating 30 frames per second at a rate of 2 seconds. I'm creating basically 58 frames. So at 2 seconds, it's going to be 30 frames per second. 30 frames per second. At 2 seconds, that's 60 frames. And I already started with 1 and I end with 2. So it's going to generate 58 frames. 60 minus 2. And there's some prompts. So it's also taking in a prompt. Walking Man. Is this going to work? This is kind of... Oh. This doesn't cost money, does it? Oh my goodness, this is insane. Let's go to the GitHub repo. Oh my goodness. Dude, this took so long before, like, costed a lot of money, and I feel like they're clearly using copywritten stuff. Ghibli Studios in particular. Calm down. Our framework opens up the era of generative cartoon, but due to the variety of generative video prior, success rate is not guaranteed. It's open source research exploration. Instead of commercial products, it can't meet all your expectations. This project strives to impact the domain of AI-driven video generation positively. Users are granted the freedom to create videos using, but they are expected to comply with local laws and utilize it responsibly. The developers do not assume any responsibility for potential misuse by users. Cool. Oh. Does it cost money to run on 0? Oh no, what? Error. Cost. Does it cost money? What is this? Who pays for the spaces? Do I pay, or the, like, it seems like I would be paying. Or does the person who's hosting the model pay? I'm confused. Okay, well, that's fine. I mean, this is a cool project. It's good to know about this one. Let's try something simpler, shall we? What is this? AI comic factory. Anonymous users can generate one comic. Sign up to Hugging Face to make more. Cool. Let's do text. Wrote an image to 3D. Auto quizzer. Generate a quiz. Or let llama play. Okay, so interesting. So Rainforest Alliance, this is telling us about capybaras. So I guess I could point like a wiki and it will generate a quiz. So let's click on generate quiz. Oh, it's done. Oh, this gives me ideas. Auto quizzer generates a quiz from a URL. You can play the quiz or let the MML play it. What does that mean? What is the typical weight of it? I don't know. Less than 20 pounds. It's tiny. Where are they found? I don't know. Forests? What's the primary in fruits? Maybe insects. What's a unique feature? They are located on the sides. Sure. What's a unique ability? They can hold their breath. Yeah, sure. Let's admit it. See, more than what? Wait, hold up. Is that right? No way. Whoops. No. They can weigh more than 100 pounds. This little guy. Well, I learned something today. Oh, that's cool. Vegetation. Okay, sure. I can believe that. They are looking on top of its head. Top. Similar to a hippopotamus, the eyes, nose, and ears are looking on top of their head and allowing it to peek above the surface. Yeah, I guess I can kind of see that. And they can hold it. Okay, sure. What if we let the... It can do close book. It knew that. It knew that. 45. That's interesting because it says 45, but it says they can weigh more than 100 pounds. 45. Whoa. What if it did with WebRag? So RAG is result augmented generation. Basically, it can go out and grab more data to augment its generation stuff. This should be 100, right? So it goes out to the web. 80%, that's funny. It's probably the same. $50, what? I mean, the question is kind of weird, but this is cool. Auto quizzer, huh? Alright, alright. I'm paying attention. That's neat. What's grok? What's haystack? Leading. What is this? It's an open source Python frameworks by DeepSet for building custom apps. Okay. So you can build semantic search, generative question answering, natural language chatbots, agents, information extraction from documents. That's an interesting one. But what's the point? To deploy your final system. You don't need to understand how the model works under the hood with ASAC's modular and flexible components, pipelines, and agents. All you need is some basic knowledge of Python to dive right in. Okay, it's a tool, I suppose. Retrieval augmented. Interesting. I feel like I need to play around with that at some point. It's probably a lot more important than I realize. Okay, I want to do one more thing here. Like, okay, how about this? Death Note. Wikipedia. Okay, so I'm gonna grab this. This is gonna be interesting because this. So one of my favorite animes is Death Note, and here's the Wikipedia for it. So it's all about, you know, this character. It follows Light, Shinigami Ryuk, 37 episode anime. A lot of facts, right? There's a plot, manga. Okay, I'm kind of curious. What kind of quiz is it gonna give? Let's try it out. Fiat Panda. I don't know what that is. All right, let's generate. Oh man. Okay. Who wrote Death Note? This. Oh come on. No, but okay, I don't know. Ryuk and L are characters. And I don't actually know. Like, there's two Japanese sounding names. Like, obviously, it's gonna be one of these names. What is the name of the animation television series adaptation? It's just called Death. What? This is not a real. Okay, I don't know how I feel about this quiz anymore. It's like kind of obvious, right? What is the name of the Japanese manga magazine where it was serialized? Well, I mean, I don't really know any of the other ones, so I don't know if this is a good question either. Who is the protagonist? Okay, that's this one's actually a good question. All of these are actually characters. Light should be the protagonist. I think the protagonist means the main character. L is the other main character. Ryuk is like kind of partners with Light, and then Misa is Light's girlfriend. So it's not Misa. I don't think Ryuk doesn't count as a protagonist. The only other possible protagonist would be L, and that's just because I don't know the meaning of the word protagonist. But it should be Light. What is the name of the Shinigami who owns the Death Note? I think. Well, this is kind of a weird question because it says who owns the Death Note. In the series, there's actually multiple Death Notes. Okay, sorry, I thought I heard some noise outside. There's actually multiple death notes. And this is kind of dumb because, well, Shinigami. What is the name of the Shinigami? There's no Shinigami named Shinigami. That's not it. L is not a Shinigami. He's a regular person. So C and D you can eliminate. Rem is actually interesting because Rem is a Shinigami. And Rem does own a death note. So I kind of don't like this question because I feel like A and B are both correct answers. They both own death notes. They're both Shinigamis. And that's the actual name of both of them. But they're probably only asking about like the main one, the first one they introduce is Ryuk. Rem is like introduced a little bit later, and like the main death note is the one that belongs to Light. So that's probably that one. Well, let's see. Okay, yeah, this one I don't know who wrote it. I guess Oba? Is that Oba? Yeah, okay. So cool. I'm pretty happy with that, I suppose. I mean, you know, I mean, I guess I'm happy I got it right, but then again, it's kind of obvious. But let's see if the AI can do it. Let the LLM play. Let's try it out. So let's try close book. Wow. Too easy. And this should be the same. It doesn't even need the web. Plus, if it got the results from Wikipedia, of course. Top 3 snippets. Funny. Is he Google searching it? Luke. Arma is a white Shinigami whose appearance is somewhat based on a real Jesus. She brings one of the new 6 death notes to the human world. So like, see, this is an answer too. But that's cool. Auto quizzer, huh? Wow. What is Grok? What is Serper Dev? This is like a world of programming I don't know about. Oh, okay. So Serper is a Google API. And what is Grok? What is Grok? A infrastructure company that builds the world's fastest AI inference technology. LPU inference. Okay. So it's kind of like ChatGPT. But I guess they run on specialized machines that runs it quickly. It has LPU has greater, what is L? Language processing unit, hardware, okay, this new. So it makes LLM faster. And you can't use it to train, but you can use it to run inferences. I think that's what they call it. Okay. I guess it's just about speed, which is kind of cool. Oops. I wonder what other ones. What is this? What is zero GPU? There's just so much to play around with this. Hugging Space is great. I feel like you can do it with GitHub. Like, it's basically GitHub. They could have put this on GitHub, but I think their integration with like Spaces and just making AI more accessible, it's a great idea. Great idea. It's like targeting it, which I'm all up for. Okay, I think I'm gonna call it and get ready for bed, do other stuff. So yeah, thanks for joining my exploration of Hugging Space. Hope you have a good rest of your weekend, and I'll see you next time. Night.